Hopefully that's okay. All right, everyone, I'm going to start. Yay, okay. Thanks, Julia. Okay, so today I'm going to talk to you about interactive data visualization with D3.js. So if everyone could go to this link right here, it'll take you to a website that looks like this. So I'll go back. Everyone good? Okay, cool. So what you should all be seeing right now is a little website that I made for this tutorial. If you click on this first link, it'll take you to this webpage, which we will all do soon. What I'm showing here is a small interactive plot that the tutorials will teach you how to make. So hopefully by the end of this, you'll understand the components that go into making something like this. So what this website is doing is it's pulling data from MRI-QC, which Russ talked about earlier today. And MRI-QC returns a bunch of QC metrics. And there's so many that you can't just have one plot to describe them all. And so what you can do on this website is click a drop-down menu and choose to plot full width half max in the X direction. And you have a nice little plot that animated a little bit. And you notice that when you put your mouse over one of the bars, you can see that the scatter plot below is also highlighting for that particular point. So the outlier on that full width half max histogram is also an outlier on this contrast to noise to SNR plot. And also it works the other way around. If you want to know which bin this dot here applies to, it's also up there. So we have the outlier on one side here and the outlier on the other side here. Pretty interesting, I think. You can also change the variables here. So now I'm going to plot this SNRD-WM, and it's the same idea. So we have this little interactive plot, and it's made with D3.js, which is a JavaScript library. So why is data viz important, interactive data viz particularly? And I think it's because our data sets are getting larger, and this is a necessity, as Russ told us earlier today. Our data sets are very multidimensional, and the relationships between variables are getting less intuitive because there's just so much. And also I think in our field we need ways to connect information visualization, which is box plots, bar plots, with scientific data visualization, which is MRI scans, our statistical maps. And so one small example of something like this is a small app I wrote called RoyGBiv. And here we have our scientific data visualization, our standard free surfer labels. But when you shift and highlight over a label, you can see a box plot of distributions of different shape measures on the other side. And so in this way, you can interact between different parts of the brain and their different distributions. So what is D3.js? Why is it called D3? It stands for Data-Driven Documents. And the idea is that it's a JavaScript library that manipulates the view that you see on your website based on underlying data. And if you click on the examples website, there are so many beautiful examples that some of us definitely want to use for our data. My favorite is this hierarchical edge bundling for connectomes, because you can highlight over a particular connection and you can see how it connects to different parts. And it's bundled like hierarchically, so you can kind of see groupings of the different nodes. And you can also play with how you want to look at the view. So I think D3 is super powerful and useful. The problem is that it's really hard because the examples aren't very reusable. If you're using Python matplotlib, everything's kind of there for you. You put in your X variable, your Y variable, you choose the type of plot you want, and it works. But D3 is not the case. So I think that everyone should at first look at some D3-based libraries to see what works for them. Here's an example. Here's a set of ones that I like. Plotly's pretty cool. Vega's nice. DC looks cool. I haven't figured out how to use it yet. These libraries are really great, but often I find that I need to tweak them for my particular purpose. And so in order to do that, I need to talk about the basics with you. And the goal by the end of this tutorial is, I don't expect all of us to become D3 whizzes, I'm not, but the goal is to understand and adapt the existing examples for your data. So the basics are that there are 3 parts to all websites. There's the HTML, which has just describes the content of the website. There's CSS, which stands for Cascading Style Sheets. That's the style. So this has a black background, pink text, and JavaScript, which is the scripting language to interact with the different components on the web page. So for this tutorial, we're going to be using CodePen. So you can click this link, but you can also just go to the next slide so I can talk about this. Has anyone have experience with HTML? Okay, so you kind of know. So you know that if we go, that the HTML, you start off with these tags. It always goes HTML, head, and body, and all your content is going to go in the body. So I can say hello world here, and it shows up in my little web page here. If we type an H1 tag, for example, it gives us a heading. So all browsers have this pretty standardized way of representing the content, and they all render it similarly. If you want to change the style, we can use CSS. So in this example, I'm going to change the color of my header to red, and now we can see that it's changed. With JavaScript, for now, I'll show you how to do a print statement, which is console.log. And now you can see the JavaScript console is down here, and it says hello world. So this is useful when you want to print in the middle of functions and see what's happening. Console log is your go-to.
Can you explain that? So it's like giving you a log of like what the website's running?
Yeah, so this website is taking as soon as you make a change in your HTML, your CSS, or your JavaScript, it like refreshes the stuff down here that's happening. So it's kind of as you're editing, you're seeing the website being created. Normally these would be 3 separate files that you import into one HTML file, but for the purpose of this tutorial, so that you all can work on it, we're going to use CodePen.
What's the relationship between the JS file and the HTML file?
So the HTML file is importing that JavaScript file and running it. Yeah.
Where?
You can't see it. CodePen is just doing it for you. If we go to a normal website, so let's go back to this website here, and if you all do view developer view source, actually no, go to view source. You can see this is the HTML that made my website. In the head, we've put some kind of administrative stuff. So here's the title. Here I'm importing some style sheets. Oh my God, yep, good point. Yep, thanks, Chris. Ooh. Okay, yeah, thanks. Is that good for everyone? So here I'm importing some style sheets. Actually, that's a font. Here is the CSS for the website. So similar to how I did, where is it? Here? Okay, cool. So the CSS that you see here is the same as this. Obviously, I've added some more things. Here's the body of my website. So you can see I have a header. It's saying Neurohackweek tutorial, and it links to this presentation. And then if you scroll down, sorry if this is dizzy, you can see that I'm importing some JavaScript. So here's a JavaScript file that I've imported. But I'm also defining the JavaScript directly in the HTML. So if you were doing this on a text editor outside, you would have to set it up like this. But I think for small little examples, I like using CodePen because it automatically updates, yeah?
So here in CodePen using Java, so we are doing the console log hello world. It's not that is not affecting anywhere to that hello world.
No, that's completely different. That's just, I can say, hi, I'm Anisha, and it'll print, hi, I'm Anisha. Yeah.
See the console.
Oh, yeah, no problem. Yeah, so the console is down here. So if you want to print stuff during this tutorial, feel free to console log different variables to see what's happening. Everyone good? Cool. Okay, so as I was saying before, HTML is made up of these tags. They start with these symbols, and they end with a slash, the same tag. You can click here to get a list of all the tag names in HTML, but don't worry about that for now. As you saw earlier, I had an A tag, which had an attribute called href. So each tag has a different set of attributes that are relevant for that particular tag. Next, I want to talk about this div tag that defines a section, and it just defines like an empty section. And it can be empty or have child elements. So really quickly, you might hear this word called DOM, and it stands for the Document Object Model. And what happens when the browser gets your HTML is it creates these objects or nodes, and these nodes have different attributes that you define. And the purpose of JavaScript is to manipulate these attributes, and that's what D3 will be doing as well. You guys can all see this if you do View, Developer, Developer Tools. So now you can see, if you click Elements, you can see the different nodes, or the DOM of this particular presentation. Okay, so now if you have your CodePen open on a different tab, you can copy and paste these 3 lines. And these are just empty elements that have some text. So here I'm creating a div that has a width of 100 pixels. And in the CSS section, I'm adding some style to these empty sections. And what happens when you do that is we have our first mini bar graph. So go ahead and play around with the CodePen. You can change the color of the bars to red in the style. If you scroll down to the body, you can copy and paste these div tags and maybe change the width to, okay, make that really big, 1,000. You can type whatever you want here, right? Is there a question? Okay.
So is bar implemented in CSS?
So basically what I'm doing is I'm defining a class bar in my div. And so any element in HTML that has this class bar is going to follow these style rules. So if I remove class bar from this last bar that I just added, and I just delete it altogether, it has no style. It's just in text. Yeah? I can give it a new class and give it a new color, and that will change the style of this. So even though they're both divs, one of them has a different class, and so therefore it has a different style. And this is how we can group similar things. You'll notice what I haven't put in the style is the width. So even though these are all bar classes, they all get these style features, but the particular width changes between elements, and that's because each bar in our bar graph has a different length. Yeah? Everyone good? Okay. So just to review again, we defined a class for the style of our divs. We called it bar, and they all had the same style, and each div had its own width to, give it its own width. But this is kind of way too manual for us. We want to like automate this process. We don't want to have to type div all the time with different widths. So that's where JavaScript comes into the picture. And we can dynamically add bars to our page. So if you were to copy and paste this into the JavaScript section of CodePen, you will see that a new bar has been added. We haven't specifically defined it in our HTML. But in our JavaScript, what we've done is we've gone to the DOM and we've asked it to create a new element called div. We've given it a class bar, we've given it a width, and we've appended it to the DOM right here. We've appended some text to it, and we've appended the entire object to the DOM, yeah?
So is that part of what JavaScript does, is it essentially interfaces directly with the DOM?
Yep. Yeah, and that's what its purpose is. So you guys will notice anytime there's the view of your website changes, if you're on Twitter and a new tweet comes up, that's because JavaScript is actively going in and like changing it and adding new elements.
So it's not like adding new HTML and then refreshing some portion of it, it's just adding.
It's just adding it, and then the browser knows to render it when you add it. So it's not refreshing the page, no. Yeah, it's pretty cool. Okay, everyone good? Yeah?
So is JavaScript like HTML?
It is.
Okay.
So if
Is it changing HTML?
it is changing, but the page isn't refreshing, so it's not going back to the server to get the new data.
I kind of thought of maybe like HTML builds a DOM and then JavaScript touches this part, it doesn't actually touch this part?
So maybe I just know that when you view the source, if you were to view source of this, so I can do that right now, you'll actually see a new div. Yeah, so the HTML has shown up here because we added it. So definitely it's manipulating the DOM. Maybe that's also changing the underlying HTML, but it's not doing a refresh of the page. Okay, so now we want to interact with our data, right? That's the whole point of doing this. So if we were to use vanilla JavaScript without D3, you would grab all the elements with the class name bar. You would loop through them. So this is how you do a JavaScript for loop. And you would add a function. It's called add event listener. So when the user clicks on this element, we're going to change the style's background to black. Okay, so this is a little lengthy. But now you can see when I click on this bar, it turns black. And I can make all of them black. So cool, you don't need D3 for any. You can just do, normal JavaScript. But people didn't like doing this. It's kind of really annoying to do all the time. So enter D3. It makes this whole DOM manipulation a little bit easier. So that exact same plot we can do with these few lines of code. So all you would need to do on the HTML side is just put one empty div with nothing in it and give it an ID. So it's just another attribute. And what we do with D3 is we point to that div, and here we're doing a bunch of stuff, which I'm about to explain. So really quickly, just to prove, same stuff as before, except now I'm not actually writing any HTML. I have some data that I'm rendering to our HTML, to our DOM, and these are the D3 lines that are doing it. So what does each line mean? So first we've defined some data as a list. For those of you who know Python, the syntax is pretty much the same. Then we're going to select the element that we want to append all our elements to, yeah? So this is d3.select. Hashtag means look for an ID with plot area. Then we need to select any elements that have the bar class. So you'll notice that hashtag corresponds to the ID attribute of your elements, and dot corresponds to the class attribute of your elements. So now we're going to the plot area and we're selecting any .bar classes. And then we're going to bind data to it. So if you were to look under the hood, after running this last line, you would see that your data has a new attribute. Yeah?
How does the language know that it has to use this library? You don't import or set up?
Yeah, so if we weren't using CodePen, I'll show you CodePen very quickly, how you can import it with CodePen. But in my earlier example, at the bottom of your HTML page, you can import the D3 library, and there's a URL for that. Okay, but this part right here, this data binding is key to D3, right? Because now all of our elements know that they have some data behind them, and we can use that information to render them correctly. So select all, and .data. You'll see that in every D3 example. Okay. When you bind data, none of the elements have been created yet. We have to do that creation step, and so that's what .enter.append does. So this is just creating the divs. After you've run this line, you'll see that new divs have been created, but we need to give them some style, otherwise they're just blank, right? So .attr says give it the class bar, but in our earlier example, each bar had a different width. So then we give it this .style method. And this is a little tricky. This might look weird to some of you. I kind of hated it when I first saw it, but the two arguments that are going into this .style function, the first is width, to tell us, okay, these divs need their own width. And the second argument is what they call in JavaScript a callback. So when D3 runs this is the equivalent of their for loop that we had earlier, except now all we're doing is we're giving it a function that takes in one item. That item is our data, but it's the data for that particular element. And we're saying the width needs to be that data, but in pixels. So we're adding .px. A little bit, yeah, but it can be multiple lines. Yeah. So.
And usually in Python Lambda, you define what the inputs to the Lambda were. Usually in a
JavaScript callback
Yes.
function from which you're calling a callback is going to give you is going to have a certain set.
Certain sets. So you have to know beforehand that this style function is going to run a callback and it's going to give it one element. Actually, it gives it two, but one element, and you have to know that beforehand. So looking at the D3 documentation is pretty vital here, but most of them follow this pattern. If you gave this function two elements, the second element would be the index of the data, which is useful sometimes. JavaScript doesn't complain though if you just give one. It's an annoying language. Anyway. Okay, and then again, this .text, based on the bound data, we wanted to add that little label for the length of the bar graph. And then finally, this .on method, again, takes a callback, and what you can do with this data is whatever you want. So in this case, we're going to select the data using this. This is a special JavaScript keyword, but it's saying this is the actual element, the DOM element that was clicked. So we're selecting it and we're giving it a style. So we didn't use D in this function, but you can imagine you might want to, right? If you wanted to click on a dot and display the subject ID of that dot, the data is already there for you. Okay. So now I want to talk about transitions. A lot of D3 has these beautiful transitions and it can make things very pleasant to look at, but also I want to show you an example that made beautiful use of transitions. This is called r2d3.us, and I'm just going to scroll through it really quickly, but it's a machine learning tutorial, and it's just beautiful. Look at the points, and they're talking about boundaries, and then look at this. I love this. I think it's really great for communicating your results if you add a little bit of animation. So with D3, it's very easy to do so. Earlier, we had these lines, actually these three lines, right? So we selected data, we added it to the DOM, we gave it a class bar, and now I'm setting the width to 0 initially, adding a transition and saying it needs to be 1,000 milliseconds, and then during that time, it's going to grow to the width, and it's going to add some text. So to show you what that looks like, oh, nope, I'm telling you more. I'm adding a few more callbacks here on events. So when you mouse over, I'm going to change the background to black, and when you remove your mouse, I'm going to change the color back to blue. And now when you click on a bar, I'm going to add some animation. And I'll show you what that does now. So let me refresh this. It's supposed to grow. Okay, it grew. When I highlight, you can see that my mouse events are working. And when you click on a bar, it's kind of bouncing and it's growing. So not useful, but kind of fun. So let's look at the code again. Yeah?
Earlier you mentioned something like it's hard to just grab some D3 code and reuse it. So
Yeah.
It would be hard to take that introduction to machine learning and even though it's still a bunch of points.
Yeah, it's not straightforward unless you're used to looking at all this. I found when I first looked at D3, I found all these this dot notation. I found it really weird and non-intuitive. Okay, I'm seeing some nods. That's good. Yeah. There is no for loop. Yeah. So D3 internally knows that each element that you've added is going to have some data attached to it, and it knows that you're going to be looping all the time. So width, for example, it's taking in this function and it's running this function on each element that you've added. Does that make sense?
So each of these.
So each div with class bar that we've added, it's going to get a style called width, and the style of each element is going to be whatever this function returns for that element. So if the first bar has width 50 pixels, then internally that data is represented on the DOM, and it's being fed into this function, and the function is running and returning 50 pixels, and then D3 is like, oh, okay, and it's making the element the correct width.
So it doesn't really matter what you call an element, or what you call a variable in each element. So function D, it could be function anything, and it could be different for each of the.
Yeah, it can be different for each of the elements, and that's key, right? That's what we want. Yeah?
So if you wanted to have also a color associated with each part, would you then have a second function
Yep.
mapped on?
Yep, you could give it another style. So dot style I think it's background. And then here you would like return, I don't know, some color map that takes in the data and returns the right color.
So then you have like a dictionary type thing that goes to that.
Yeah.
And translate it.
Yep, and there's some D3 helper functions that if you look on the website, they give you some nice color mapping functions.
This dot, like the dot notation, whatever's farthest along is the one that gets implemented?
All of them get implemented.
And then what if there are two different flags?
Then the first one will run and then the second one will undo it.
Okay.
But you probably wouldn't see the difference because
You wouldn't see it because it happens quickly unless you throw a transition in, right? So initially I set the style, the width 0, and then over 1,000 milliseconds I then set the style again.
But
But
it's in time, it's not like CSS.
what do you-
For some reason I was thinking about like,
oh yeah. But if I didn't have this transition, you would never know that the width was ever 0. So I'm going to delete this.
it would just do it.
Because it would just do it super quickly, yeah. So I'm gonna save this so I can refresh it. Okay, so you didn't see the transition that happened there. I hope I can undo what I just did. No, I will fix it later though. Actually, I can just do it.
You just go to step 6.
Oh, I just saved it. I deleted that. Anyway, it's fine. Okay.
And what if we want to do different things to each of our bits which belongs to the same class?
So that's where your class definitions are going to matter. So I specifically didn't put width in here because then it might set the width all the same initially. But because you're passing data in for each element, you can change things on the fly for each element.
And can we read in that data? For example, now you have a standalone, like you initialize data.
Yes, you can import data. So going back to the like home site, this data came from MRI-QC. I didn't encode it in the HTML anywhere. So we'll talk about that later. I'm gonna move on. Okay, so actually that's kind of relevant. So let's imagine we have some real-time data streaming in, or let's say we want to dynamically change the metric that we're plotting, which is what we saw. So what we're gonna do is in our HTML, we're gonna add some buttons above our plot area. And these buttons, you'll see they have this on-click attribute. And this is a JavaScript function that we have yet to define. So when you click a button, it's going to add data. When you click this button, it's going to generate some random data. And when you click on this button, it's going to remove some data. So what I'm going to do is I'm going to take those same lines that we had before and wrap it inside a function that takes in a data variable. And then I'm going to call the function on the data. And here are some small functions that will, this one is going to just create a random integer. This is going to add that random integer to our data variable. This is going to just completely change the data variable, and this will remove the last element of the data. And so the idea is that when we click our button to add data, a new bar will pop up. If we click randomize data, it should randomize our bars, it should be different. When we remove the data, it should go away, ideally. And so I'm gonna click add data. Okay, that works. Pretty cool, right? It grows. But if I click randomize data, it's broken. And if I click remove data, it also does not remove anything. So this is the little tricky part about D3 is updating. So it's broken, yes. So what happened? This enter.append div, what it does is it only adds new divs that haven't been added to the DOM yet. It doesn't want to keep adding divs because that's going to look really bad and isn't relevant. So .enter just returns the remaining divs. So going back to my example here, add data worked because .enter returned just one bar, and then it was appended by the .append method. So to update our data, we need to kind of split up everything. First, we need to select plot area, select all the bars, bind data to it, new data, enter into it, meaning return the divs that haven't been already added to the DOM, and then append them, give the new guys a bar class, and give them a 0 width. Our next step is to select all of the dot bars, the old ones and the new ones, transition over 1,000 milliseconds, and then give it the appropriate width. and the appropriate text. Okay. And now removing, right? Removing is a different story because we need to select our main guy, we need to select all the bar classes, bind the data again, but this time the DOM has too many elements in the data. So .exit returns whatever is extra, and remove removes them. So .enter and append and .exit and remove are pretty key methods that you need to be calling in D3, and every example you see will have this for updating. Some examples don't have updating, right? They're very basic. It's like, ta-da, here's my plot. So keep in mind that when you want to adapt one of these examples, to think about enter and append and exit and remove. If you want to remove your bar with some style, you can give it a transition between the exit and the remove. So here I'm saying over 1,000 milliseconds, slowly fade my bar. Add some drama, I don't know. Okay, so now in this example, adding data, that worked before. Randomizing data, yeah, looks cool. And we can remove data. Yay! Okay, so that's, yeah? So the exit returns the extra DOM elements that aren't represented by our data. Because let's say we had 5 bars initially, we changed our data, so now it's only 4 long, and when we bind our data with only 4 to 5 elements, the last element is like returned on that exit, and then .remove gets rid of it from the DOM. Does that make sense? Okay. And this is because we don't want to keep adding new divs. We want to kind of keep everything the same length. It also means that you're not working as hard because it's not, I mean, another option would be to clear all the divs that you've created each time you run the function, but that's wasteful, right? We just want to add the little changes that we've made. Okay, so we have a pretty cool bar graph, but we have more than bars, right? We saw that cool connectome plot. And HTML alone isn't enough to render this, right? We want lines, we want circles. So now we have to learn something even more, SVG, and it's called Scalable Vector Graphics. I'm sure you all have seen image format with .svg at the end. If you were to open it with a text editor, you would see something that looked very similar to HTML. They just have different tag names and different attributes. So defining the color of a bar that's a div is different than defining the color of a rect, which is also a bar. Could be a bar, yeah? So next up, we're going to do that scatter plot from my example. But before we do that, when we're drawing on an SVG, we need to transform our pixel coordinates to like data coordinates or vice versa. Take our data and map it to pixels. And this is kind of annoying to do, but D3 has functions to help us do this. So now we're going to create a new function, and all it's going to do is render an axis. And we're going to define margins on the axes. And this is because our x-axis and our y-axis, we don't want them at the edge of our SVG. We want them offset a little bit so we can see our labels. And I'm also going to define the width and the height of the SVG. So I'm just defining stuff here. I'm not applying it yet. Our next step is to create some scatter plot data. And you'll notice my format of the data is different. So now it's a list of dictionaries if you're used to Python, or an array of objects if you're doing JavaScript. You'll notice you don't need to put quotes in JavaScript for your keys. You can just put this and it knows it's a string. And now we're going to have these function selectors. Before, we knew our data was going to be a number because it was just a list. Now that we're appending this more complicated data, I find that it's useful to define these little helper functions. So if I want to get the x value of my data, I have a small function defined that returns the x key value pair. And because D3 is going to run these little functions, I defined this beforehand so I don't have to keep typing it out. So we have x value and y value. Next, we need to define the transformation between data and pixels. So we need to know the pixel length and width, or height and width of our SVG. So this scale linear is a function that you can set a range on. So here I'm saying x is going to go from 0 to whatever width in pixels of my canvas. And y is going to go from height to 0. And that's because in an SVG, and I'm sure those of you who've used Python's IMShow, y is at the top, y equals 0 is at the top, I think, right? And as y gets larger, it goes to the bottom. And so when I define the range here for y, you always have to flip the height. Okay. So the next thing you want to do is define the domain. So all of these axes, these like transform functions, have a range and a domain, where range corresponds to pixels and domain corresponds to data. So now our data, I'm using this d3.min function. Its first argument is all of the data, which is a list of dictionaries, and its second argument is a callback function. But we know that x value is always going to grab that x value of our data. So this entire thing returns the minimum value of your data, and this entire thing returns the maximum value. So here we're setting the range and domain. And so on the next step, we'll see that if we run this xScale function and we give it this scatter data's x value, then the 2.1 that it was originally in data units is now 280 pixel units. So we do that here. You can see that the console that I logged is showing here. I did this console log for us. So you can type x scale of scatter data of 2.x, and that's going to map to 157.5 pixels. So D3 has given us some nice little helper functions. Okay, so now it's time to start actually building this plot. So instead of adding a div, we're going to add an SVG and give it an ID so we can refer to it later in our JavaScript. This is kind of an annoying thing that you always have to remember to do, which is to add like an extra canvas in your SVG that is shifted so that you're not drawing points at like the edges of your canvas. So here I'm saying add a group element in SVG that's very similar to a div element. It's just like an empty area that we're transforming a little bit to the left and a little bit down so that we have room for like a title and stuff. And I'm going to save this variable because everything that we append to our DOM now has to be appended to this group right here. And all the D3 examples will have this. Just know it's because we're making room for our axes labels. Okay, so now it's time to actually build the axes. And D3 has a little method for this called axis bottom for the x and axis left for the y. And to draw it, you take your SVG, you append a new group where you give it a class x-axis, and this is because we want to refer to it later. Let's say you want to style your x-axis differently than your y-axis. It's a good idea to give everything its own class. The x-axis is being taken to the bottom of the SVG because the SVG is opposite in height. And then the y-axis gets called. So now it will be drawn. Yay! Axis. Okay. Cool. So now what's left to do is to create some elements that we want to draw on this axis. Using our new x-scale and y-scale functions, we can map our data to pixels. And then we have to remember to always update our data and remove it if we want to change variables or something. So now to clean up our code a little bit, I'm going to have my render axis function return an object. JavaScript's really annoying because you can't return multiple things like separated by commas that you do in Python. So you can't return two separate things, but you can return an object or a dictionary with these key value pairs. So now AX has all this useful information that I'm going to use later on to put my scatter points on the thing. Okay, so when we run our scatter point function, the first thing I want to do is just reset my domain in case my data has changed and I need to like squish the axis or make it bigger. And I'm going to redraw it. So again, because we gave the x-axis this class, we can now redraw the x-axis. And now we have dots coming on our screen instead of divs. So I'm giving all my circles the dot class. I'm going to give it a border. I'm going to fill it steel blue and give it a radius. So these particular things all are SVG circle specific. So SVG has a ton of other elements, and when you're trying to make something custom, you want to like Google what all the different attributes are and like customize it for yourself. So I like didn't memorize this, I just like Googled, okay, these are all the attributes I want to change on my SVG element. So I'm going to select all with dot class. So if there's nothing on there, that's fine. I'm going to append some data. I'm going to bind data and append SVG circles. And I'm going to give them the dot class. So now everything is going to have a border, a steel blue fill, and a 7 radius. 7 pixels. Next, I'm going to select all my dots, add some transitions. In this case, I wanted to go with the look where the dots start at the top and they like fall into place. So I'm setting the X value, and then over 1,000 milliseconds, the dots will go to the Y direction, the correct Y position. And you'll notice that my callback function is using X scale, and it's also using my X value function that I defined earlier. So it's plucking that X. So you don't have to do this, you can just write it out all the way. You could even take this entire thing and make it its own function, so it doesn't look so ugly. And then we have to remember to remove our dots from the DOM if we're updating our data. So again, it's the same thing, exit and remove. The only different thing is now we're using dots instead of the bar class. So now, I'm going to refresh this so you can see the transition. Okay, cool. So now all that's left, the steps between step 9 and step 10 are, it's kind of a lot, so I kind of leave it to you to figure out. But the key points to know is D3 has some functions for grabbing remote data. So if you have data sitting in a CSV file, you want to use d3.csv. If you have a JSON file, or if it's sitting on a remote API, and you know you're getting JSON data in, use d3.json, and then TSV is for tab separated values, if you're into that. So in our example from the beginning, I was using MRI QC data, which I know comes to me in JSON format from this MRI QC database. So that's one thing I added. This is how you use the function, again, with callbacks. So the first thing is you use the URL of your data, and then the second item is a function. And so all the good stuff happens here. Once the data is loaded, make my plot. Another thing in HTML that's useful to know is that this is how you do those drop-down menus. So the tag name is select, and within select, you need to have these different option tags with a value and a name. And then another useful D3 method is called .each. And so this lets you iterate through each of the elements in your function, and you can do whatever you want with it. So earlier we were using .style and .class, but the .each you can do whatever you want within it. And so this was useful because when you hover over a scatter dot, I wanted to iterate through all my bars in the bar graph and select the one that corresponded to my dot and color it a different color. So that was .each. And so what you get in the end, and you guys can all play with this code and mess around with it, is the highlighting feature and the linking between the two plots. And you can change, oh yeah, so some mistakes here. So when I ran the D3 histogram function, it gave me these bins. And so D3 actually has some functions to like fix the formatting of your numbers. So that is something that you guys might want to add. Yep. So to summarize, there are kind of 4 things you need for D3. It's not just a JavaScript library. I mean, it is, but you can't use it unless you're familiar with HTML, SVG, and CSS. So there's kind of a lot of things to know, and that's why it's so hard. The first thing that every D3 example will do is select the relevant parts of the DOM. Then it will bind data to it with this .data. Then it'll set some styles and some attributes of these different DOM elements depending on which element you've added. If you want to add a listener for a click or a mouse over or double click or a right click, use this .on method, where the first argument is like the type of event, and the second thing is a callback function. To update your data, it's really important to remember to enter and append and exit and remove, otherwise things will not work and you will be sad. And then the very useful axes functions that can map your data to pixels. So I think there's some really cool examples that bind these 2D plots with 3D scientific data visualization. I showed you Roy G. Biv. Mind control is something I worked on. AFQ browser from Jason Yateman's lab shows you streamlines, and when you click on a streamline bundle, you can see a plot. That's very cool. MetaSearch has, I'm going to show it. Yeah, sure, I'll leave. Has a parallel coordinates plot, which I really like. I'm going to skip this. And so the idea here is you're seeing many different metrics plotted all together, and the relationship between the metrics plotted. And you can like select, I don't know, I only want to look at autism data sets. And now it shows you all the different open autism data sets, and you can click on this Brainbox link to load the image. And then I'm currently working on a crowdsourcing app to crowdsource segmentations. And so I wrote a little dashboard where you can click on a dot and you can see how well I segmented the particular image at that day. So D3 is very useful. I made this plot from scratch. I didn't use any of the libraries because I wanted to be able to bind an image with a click. So I think there's some amazing resources out there, and you all should Google them. I use these, and here, this one, that connectome plot that I showed earlier, I made one for this is a diffusion connectome. And so you can see the different free surfer labels here, and when you highlight it, you can see like the connections. So I know there are a lot of graph people here that if you wanted, you could take this example and maybe add another like 3D brain, and you can see in 3D the different nodes. I think that would be cool. So if you have any questions, we have 5 minutes. Yes?
Have you worked at all with basically ggplot too?
I have not. So there are some really great libraries that can interface the JavaScript, so you don't actually need to do it. I'm not sure, I don't know do you know if R is working on any sort of interactive? Maybe, but I do know that MPL D3 is worth looking into because you can take a matplotlib plot and then it can render D3. Plotly, also you can start with Python and it will give you a D3 plot. Yeah?
Plotly will do ggplot.
Okay, there we go. Plotly will do ggplot. So Plotly's pretty cool. I found that I originally wrote my plots in Plotly and then I wanted to tweak it and it was kind of annoying to do, but I don't know.
MPLD3 is abandoned now.
Oh, just kidding, it's abandoned.
But you can use it, but it's not being.
Is there a replacement?
Yeah, is there a replacement?
Not that I know of.
Huh.
So, Bokeh is kind of.
Oh yeah, Bokeh is another one. Do they use D3 in the back?
Oh yeah.
Oh, they do?
I think so, yeah. No, not D3.
So you don't need to use D3, right, to manipulate the DOM. You could do whatever you want. Yeah, the same idea is that you can get interactive plots without learning JavaScript, but if you want to take some really cool D3 examples, hopefully you now know how to read the code a little better, and you can edit it. Huh?
Shiny through R does.
Okay, cool. Shiny through R. Yes?
Can you just show us if we had like a pure code and we wanted to Google like which bar it was that SVG is there and tag? We're not importing the library, right?
No, so SVG is native to the browser, so we can just render it. Let's go back to...
But usually when we have like, how do we know what to Google?
Oh, what to Google? Again, I start with the D3 example that I like, and I say, oh, they're adding this tag. What is it? And I kind of just put it all together.
So you Google the tag.
Yeah, like SVG, draw a line, and it'll tell you how to do it. But I start with the examples. They're really beautiful. They just have to be tweaked. Yes. Okay.
Thank you.
Ooh. So Dylan is up next, I think.
There's a couple.